Let's look at the next type of question, question type 5. The equilibrium constant for water, sometimes called the ionic product of water, is the concentration of H plus ions multiplied by the concentration of OH minus ions. So H plus ions from an acid, OH minus ions from a base. It equals a value, it depends on, it changes with temperature, but at normal room temperature it's 1 times 10 to the minus 14, but that value anyway will always be given to you. But you need to learn this equation. This equation will not be given to you. Write an expression for pH, that's easy enough, we've done that before. pH equals minus log to the base 10 of H plus concentration. For the ionic product of water, we've just seen that, Kw, the ionic product of water, sometimes called the dissociation constant of water, is the concentration of H plus multiplied by the concentration of OH minus ions. At 10 degrees C, so the 10 degrees C, the temperature is a bit of a red herring, 0.154 moles per decimeter cubed. Solution of potassium hydroxide is a pH of 13.72. Calculate the value of Kw. So, again, why would they give you pH? They only give you pH if they wanted you to work out H plus concentration from it. So pH equals minus log to the base 10 of hydrogen ion concentration. So 13.72 is minus equals minus log to the base 10 of H plus concentration. So that's the first thing you've got to put in, because otherwise they wouldn't give you pH. So then what you do is, to get the H plus, you reverse the signs on both sides, so minus 13.72 equals plus log to the base 10 of H plus concentration. You can get rid of plus log to the base 10 by doing shift or inverse log, so you've got minus 13.72 shift log or inverse log or second function log, and it should work out that H plus concentration is 1.905 times 10 to the minus 14. Now then, what's it asking for? Kw. So Kw equals the concentration of H plus multiplied by OH minus, solution 0.154 mole of potassium hydroxide. Potassium hydroxide is a strong base, so it fully dissociates into its ions, so it's fully going to break up and make OH minus ions. So you can have this concentration of hydroxide ions because this is going to break up. So 1.905 times 10 to the minus 14 is the concentration of H plus ions. We'll just work that out. OH minus ions is 0.154. Multiply them together and you get your answer. Next question. Write an expression for pH. pH is minus log to the base 10 of hydrogen ion concentration. Write an expression for Kw. Kw is H plus concentration multiplied by OH minus ion. Calculate the pH of pure water at 50 degrees C. So pH is minus log to the base 10 of hydrogen ion concentration. So we need to find the hydrogen ion concentration. So let's have a look what we've got. Okay. Kw is the ionic product of water, and it's given you the ionic product of water, so it's given you this value. So this value, 5.4 times 10 to the minus 14, is H plus multiplied by OH concentration. Now in water, when water dissociates, H2 dissociates, the concentration of H plus and the concentration of OH minus ions are exactly the same in pure water. If you add something else, obviously these can change. So if you add some acid or some base, it can change. But in pure water, H2O water breaks up, fully dissociates, doesn't fully dissociate, dissociates, breaks up into H plus and OH minus ions. So they're going to be the same. So that equals H plus squared. So if you square root 5.48 times 10 to the minus 14, it comes out as 2.3 times 10 to the minus 7. And then if you want your pH, then pH is minus log to the base 10 of this, and that works out as 6.63. Don't be worried by the fact that pure water has a pH less than 7. The temperature will change the pH of the water, so don't worry about it. Suggest why pure water is not acidic. Well, pure water is not acidic because H plus concentration equals OH minus concentration. You only end up with something acidic if you have more H plus ions in there than OH minus ions. So the pH can change, and it doesn't have to be 7, it can change with temperature, but H plus concentration always equals OH minus concentration in pure water, and that's why it's not acidic, because you've not got an excess of H plus ions. Calculate the pH of 0.10 aqueous sodium hydroxide. Right, okay. So now then, so 0.140 concentration of aqueous sodium hydroxide, that's the concentration of OH minus ions, because sodium hydroxide's a strong base, it will fully dissociate to fully make OH minus ions. So 0.14 is that there. You've got the kW, 5.48 times 10 to the minus 14. So now you've got 5.4 times 10 to the minus 14 is H plus multiplied by 0.140. So H plus is this number, 5.48 times 10 to the minus 14 divided by 0.14. You've got H plus ion concentration, minus log to the base 10 at 12.41. Sodium hydroxide is a strong base, so that looks like a reasonable value for pH. Calculate the pH of solution formed when this number of moles of potassium hydroxide are added to ethanoic acid. Okay. So we've got 40 centimetres cubed of 0.154 potassium hydroxide. While we'll be given a volume and a concentration only to work out moles, you multiply 0.154 by 0.040, so you've got to put that into decimetre cubed, multiply the two together to get the number of moles of potassium hydroxide, 0.00616. You're given a volume and a concentration of ethanoic acid, so 0.02, so divide the 20 by 1000, 0.02 multiplied by 0.154 is 0.00308. You've got the moles of ethanoic acid. When you've got an acid added to an alkali, you always work out what's in excess. We've not got sulfuric acid, so we've not got superacid. So 1 mole of acid reacts with 1 mole of base. And so let's work out what we've got most of. We've got most of the KOH, the potassium hydroxide, we've got most of, and if you subtract the two to get two away from each other, so 0.00308 moles of ethanoic acid react with 0.00308 moles of potassium hydroxide, but you've got more potassium hydroxide than that, so the amount in excess is 0.00616, take away 0.00308, and it comes out as 0.00308 actually. So the number of moles of potassium hydroxide is this. Now, if I can get the OH minus concentration, OH minus concentration is the number of moles divided by the volume. So the volume now is 20 add 40 is 60 centimetre cubed. 60 centimetre cubed, 60 divided by 1000 is 0.06. So if I divide the number of moles by the volume, 0.06 in decimetre cubed, I end up with 0.0513. I've got the concentration of OH minus ions. So if the base, the hydroxide, potassium hydroxide or sodium hydroxide, is in excess, then you work out the concentration of OH minus ions. You use Kw then, because we're going to try and find out H plus. So if this is in excess, OH minus, we need Kw. We've got this value. You've been given a Kw here. So Kw is 1 times 10 to the minus 14. You've got OH minus ions. You just work that out, 0.0513. And H plus is here. So this number, 1 times 10 to the minus 14 divided by 0.0513 gives you H plus concentration, and therefore H plus concentration will be 1 times 10 to the minus 14 divided by 0.0513, and then if you minus log to the base 10 of that, you'll get a value 12.7. That seems to be correct, because KOH, potassium hydroxide, is a strong base, and that's in excess, so it's going to be the higher end of the pH scale. 25 centimetre cubed sample of 0.62 mole decimetre cubed nitric acid. Why have you been given a volume and a concentration? Because you want to work out moles. Multiply the two together, 0.025 in decimetre cubed multiplied by 0.620 will give you the number of moles of nitric acid. Okay, that should say nitric acid, not HCl. It should be nitric acid that, but I've worked out the number of moles of nitric acid as 0.0155. Okay. Sodium hydroxide, we've got a volume 0.0382 is the volume in decimeter cubed, multiplied by the concentration 0.55, and that equals 0.021. You've got the number of moles of each. Now HCl, unlike sulfuric acid, is not a superacid, so it's not a diprotic acid. It's not going to react with 2 moles of sodium hydroxide. They react equal amounts. So if I take those two away, and I find out that the bigger of the two is NaOH, 0.021 is bigger than 0.0155. So I'm going to end up with sodium hydroxide in excess. How much? 0.021. Take away 0.0155 is the amount of sodium hydroxide that I've now got in excess. So when these two neutralize each other, I end up with 0.00551 moles of sodium hydroxide in excess. What do I have to do next? Well, number of moles of sodium hydroxide, I need to get into a concentration. So I need to get into a concentration so I can use Kw. So concentration 0.00551. What's the new volume? Well, the new volume is 25 add 38.2. That equals 63.2 centimeter cubed. So I've got 63.2 centimeter cubed of solution now. Divide by 1000, 0.0632. So my concentration of OH minus is the number of moles of OH minus 0.00551 divided by the volume that I've now got, which is 0.0632 in decimeter cubed. So 1 times 10 to the minus 14 kW is the H plus concentration multiplied by 0.00551 divided by 0.0632. I resolve that and it works out to be 0.0870, so I do that bit first, and then H plus ions will be 1 times 10 to the minus 14 divided by this number on the bottom, so that ends up at H plus concentration 1.147 times 10 to the minus 13. pH it, so minus log to the base 10 of it, so pH is 12.94. Seems sensible if I've got sodium hydroxide, a strong base in excess.